Now you got the ones that you thought were U sub, but they're not. So I'm going to try to go through the same thought process you might go through. You're like looking at this and you're like, oh yeah, I'm going to U sub this dog. And so you go U equals 2x plus 4 because it worked before, it must work this time. And then you went du dx on this side. On this side you get 2. And then you move the dx over, and then you look over at what you have, and you notice your problem. This will become a u, and I don't see a 2 dx, but I could put 1/2 here. I see an x or dx, so I could put in 1/2 du. But what's my problem? I still have an x. Now we did do one problem, and what we did is we solved for u in here, okay. But that is a long way, and I think that way might work. I want to give it a shot one day, maybe after this class is over. But there's another shortcut that I want to show you guys, which is the purpose of me doing this problem. This is long division. Are you guys ready? So we're gonna actually do long division on this. So you go x minus 1. Do you guys remember doing this? 2x plus, no, 2x plus 4. Okay. Okay, so if I do this long division, you know what? Let's do a shortcut first. Is there a scalar I can take out? Can I take a scalar out of this? Yeah, someone said it. 1/2. You can take 1/2 out. You get x minus 1 divided by x plus 2. So if you were to distribute this back out, 2 times x is 2x, 2 times 4 is 4. So we took out the 1/2. All right, this is going to be a little prettier. All right, so here we go. We have x minus 1, and we're going to divide this by x plus 2. So if you guys can recall all the way back to Algebra 2, you look at the first terms and you divide them. What is x divided by x? Oh, now. So you just write 1 right here. And then what you're supposed to do is you're supposed to take this 1 and multiply it to the x plus 2. Now 1, maybe this is not a good example because multiplying by 1 is really simple here. So if I multiply it by 1, I go x plus 2. And then I'm supposed to subtract this. That's what the algorithm says. Now when I do polynomial long division, what I like to do is I like to distribute the negative because I always mess up on negatives, and then I just add them together. So I get negative 1/2 plus negative 2, which is negative 3. X plus negative x is going to be 0, so I don't need to write it. And since there's nothing else to bring down, then negative 3 is your remainder. So we're going to write minus 3 over x plus 2. That's the Algebra 2 concept. Now I'm going to rewrite my integrand. I have 1/2 times the square root. I'm sorry, not square root. Times the integral of 1 minus 3 over x plus 2. And then you have your dx. Now you have it split up. And what's nicer about this is now there's no x on the numerator. And you could do this one at a time. I could split this up. You don't have to write this part if you don't want to. Okay, 1/2 integral of 1 dx minus, I'm going to take the 3 out, 3 integral of 1 over x plus 2 dx. Okay, let's take a moment, take a pause, and take this in. Now there's an easy integral, and there's one that's not that simple. Okay, that's this guy right here. Now some of you guys can do this really quick, and that's cool. And if you can't, don't worry. We'll try it with U sub, and it'll work with U sub. But U sub is actually not necessary for this integrand. What is the antiderivative of 1? That's right. It's x. So it's x, and then you multiply by 1/2, so it becomes 1/2 x. Then you have negative 3, and you have to multiply it times whatever you get when you do the integral of this guy. All right, so what do we get when we do the integral of that guy? There is a shortcut here, but I'm going to take the long way because I want to make sure you guys understand. I'm going to make u equal x plus 2. What is the derivative of that? That is du dx, and then I get a 1 on the other side. The derivative of x plus 2 is 1. And so I move the dx over here, and look at that, du equals dx. And so I can easily take out the dx and take out the x plus 2 and sub those in, and this is what it's going to look like. You have a u there, and you have a du right here. So now we have an integral of 1 over u du. Do you guys know what the antiderivative of 1 over u is? I hope. Yeah, ln. Yeah, so it's going to be the natural log of the absolute value of u. And you would say plus c. Okay, but let's forget about the plus c for now. We'll put the plus c on later. Okay, now what is u? It is x plus 2. So let's rewrite it. Let's say natural log of x plus 2, absolute values. And then we're just going to put our plus c here at the end. All right. I did mess up. Anybody see it? I see my mistake. I went back over and checked my work. I see my mistake. Anybody else see it? I took the 1/2 out of the 1 and this fraction. I have the 1/2 with the 1, but I don't have the 1/2 with this guy. So this is not just 3. What is that? It is over 2. Because it's 3 times 1/2, which is over 2. So I forgot my 1/2 right there. All right, so now let's check our answers. Let's see what we have. No, I think it's this one. Yeah, it's that one. Okay. Preguntas.